General relativity rests on a single premise. Space-time is a continuous, smooth metric field, and this field is the primary primitive object of gravity. The finite distinction systems framework suggests this continuous fabric is secondary. Here, smooth spacetime is a macroscopic effect resulting from boundary accounting. FDS G1 identifies the true primitive object of gravity as a finite causal-screen entropy functional, the S-screen. The framework centers on one specific claim. Gravity-like geometry is the integrable hydrodynamic response of finite causal-screen entropy. To mechanically trace how geometry emerges from information, we have to follow a six-part formal argument, beginning with the mathematics of finite distinctions and ending with observable spacetime. Reframing spacetime as an informational boundary ledger rather than a fundamental fabric makes the limitations of gravitational coupling and dark energy mathematically predictable. Step 1 of the primitive argument establishes that physical distinctions must be actively maintained by a system. This maintenance requires a finite representational capacity. Step 2 requires a strict physical partition. To maintain a distinction, a system must possess an internal state space, X, an environment, E, and an operational boundary, B, that separates them. Step 3 maps this partition onto relativistic physics. Since physical access is restricted by the speed of light, the operational boundaries of any system are causal screens. These causal screens include light sheets, the surfaces of causal diamonds, and event horizons. Within the FDS framework, a horizon serves as the literal operational boundary of physical distinguishability. Step 4 notes that because representational capacity is finite, the causal screen holds a strictly bounded state count ledger. Step 5 defines the coordinate-free measure of this state count ledger as entropy. This is our S-screen functional. This chart shows how a causal diamond ledger manages information. Step 6 concludes the argument. Spacetime geometry is the integrable response envelope that tracks updates to this entropy ledger. The jagged blue line represents unresolved micro-boundary ripples. A finite observer averages these details into the straight orange line. Using the standard bridges of horizon thermodynamics, this mathematical resistance identifies the gravitational stiffness of the region. Gravitational coupling, big G, is the inverse of this stiffness. Gravity is weak relative to other forces because the density of distinguishability on the causal screen is high. This high capacity density creates immense stiffness, resulting in the small gravitational constant we observe. Gravity is the informational resistance of a boundary screen pushing back against area deformation. FDS G1 employs a layered defense matrix to separate its internal mathematics from external physics inputs. Stochastic transition dynamics, capacity overflow, and reach-out Drie-like capacity flow normal forms are internal FDS derivations. The 1/4 Bekenstein-Hawking coefficient and the Jacobson local screen identity are physical bridge assumptions. They calibrate the model to our specific universe. While the D0 module offers a conditional argument for that coefficient using modular anomaly inflow, FDS G1 structurally relies on the bridge to interface with standard physics. If a cosmological application fails, it archives the specific bridge assumption while protecting the underlying FDS formal core. We have traced the pipeline from finite representational capacity to screen entropy and metric closure. We must now consider the outcome when screen capacity is overdrawn and the response data cannot be integrated into a smooth metric. This chart shows the horizon capacity deficit. When task demands exceed the accessible capacity, the causal screen generates non-equilibrium entropy. Crossing this threshold forces the emergence of ledger residuals. The screen can no longer perfectly map its updates into a continuous geometric area. In observable cosmology, these non-integrable response defects manifest as the dark sector, dark energy, and the cosmological constant. When a ledger overfills, the resulting non-equilibrium entropy production occurs on a two-dimensional null screen, the surface where light is registered. This surplus manifests as traceless optical stress, altering the geometry without the need for additional energy fluids or exotic particles. Spacetime geometry and dark energy are products of the accounting limits of finite observers. Our perception of the universe is defined by the inescapable informational thresholds of the screens we use to access it.